In today's presentation, we will explore a few key architectural styles that are foundational in software engineering. These patterns are essential when designing systems that are scalable, maintainable, and easy to adapt over time. Understanding different architectural styles allow engineers to choose the best approach depending on the specific needs of their project, such as the level of the complexity and size of the team. The type of the application being developed, we will look the three architectural, model view controller and the public subscribe architecture, each of which has its own strengths depending on the use cases. Additionally, we will delve into modern technologies like virtualization and containers and exploring how serverless computing and microservices are revolutionizing system design. So, the goal of today's lecture is to continue exploring common architectural styles, focusing on tree architecture and model view controller. We will delve into more visualization and how it helps encapsulate deployments in a way that makes them more flexible and portable. By the end of the session, you should have a solid understanding of these architectural patterns and technologies that can be leveraged in modern software design to create a scalable and flexible systems. The three-tier architecture is an extension of the client-server model and is widely used for small to medium-sized web applications. It separates the application into distinct layers. The first layer is presentation tier, which is the front end, and the logic tier, which is the business logic, and the data tier, which is the database. A classic example of this architecture is the LAMP stack, which includes Linux as the operating system, Apache as a web server, and MySQL as a database, and PHP as a scripting language. The key benefit here is that each tier can be independently replaced or upgraded without affecting the others, making it highly flexible and modular. In the three-tier model, even though the presentation tier may have some internal complexity, it still remains a replaceable binary component as long as it supports the same interface. This means that the different web browsers or front-end frameworks can be used to access the website without changing the core logic. Simply, the database tier can be swapped out for another database system that adheres to same interface, thus providing scalability and easy maintenance. This decoupling of components after offers greater flexibility and helps in managing large-scale systems efficiently. The Model View Controller (MVC) pattern is used to partition the system into three core components: the model, the view, and the controller. There are variations in how MVC is implemented, such as MVC versus MVP. MVP is Model View Presenter. MVC divides responsibilities to ensure that each component has a single responsibility. For example, in the Play framework, the model contains the business logic, the view is responsible for rendering user interface, and the controller handles user input and communication between the view and the model. Similarly, swing widgets can be used to implement this separation in desktop applications. MVC promotes reusable controls and making it easier to manage the logic behind the user interface. Now let's discuss about the features and rules of the minimum viable product. The minimum viable product model has a number of key features that contributes to its effectiveness. First, it separates the presentation from business logic, making the view and the model decoupled and allowing for replacement of components without affecting the system as a whole. It also allows for multiple views of the same model. For example, a single model could have different views for web app and native mobile app. They view subscribers to the model and the use of the observer pattern to stay updated with change in state. This means that when the model state changes, the view is automatically updated to reflect those changes, allowing for real-time updates in the user interface. The controller in minimum viable product plays a crucial role in handling user input, managing application behavior, and making changes to the model. It acts as an intermediary between the view and the model, mapping user actions to change in the state of the system. The view, on the other hand, presents the user interface and sends user input to the controller for processing. This separation of concerns ensures that each component focuses on specific responsibilities, improving maintainability and scalability. This architecture also makes it easier to modify one part of the system, example changing the view, without disrupting the other parts like the model. The publish-subscribe pattern is an event-driven architecture where components communicate via events rather than direct calls. In this model, the publisher generates events and subscribers receive these events via message broker. This allows for loose coupling between the components, making it easier to extend the system by adding a new subscribers without affecting the publisher. The key benefit is flexibility and scalability, but there are challenges. It can be difficult to analyze as there is no centralized orchestration, and even and events can sometimes be dropped or respond to it in incompatible ways by multiple subscribers. The observer pattern is one common way to implement this architecture. Virtualization plays a crucial role in managing deployments by encapsulating the deployment environment. Virtualization addresses many common issues such as dependency conflicts, data sprawl, and operating system portability. With virtualization, systems can run multiple operating systems on a single machine managed by a hypervisor or host operating system, improving hardware utilization and reducing costs. It also provides flexibility by isolating applications from underlying hardware, but there are still challenges such as high overhead and state management risks. Automated management tools like Ansible and Chef can help mitigate. The serverless architecture moves beyond traditional servers by providing stateless and ephemeral nodes that are triggered by the events. In the setup, the infrastructure is abstracted away and the developers focus on writing functions that respond to specific events. Data storage services persist the state, but the application logic is split into smaller functions. This model is highly scalable but may introduce complexity in handling distributed events. On the other hand, microservices is an architecture where individual services are independently deployable and communicate via lightweight protocols like RESTful HTTP. This architecture helps reduce coupling and allow for independent scaling of services. However, microservices come with challenges such as managing inter-service communication and handling distributed transactions. Containers offers a more lightweight approach compared to traditional virtualization methods. Rather than running separate operating systems, containers share the host operating system while isolating the application's file system and network. This reduces the overhead typically associated with virtual machines, making containers start up faster and consume fewer resources. Containers are ideal for deploying stateless applications and microservices as they provide easy scalability and portability. Popular containerization platforms like Docker allow for quick deployment and management of applications across different. In conclusion, today we explored several architectural styles such as three-tier architecture, model view controller, as well as technologies like virtualization and containers that facilitate flexibility and scalable deployments. Understanding these architectures is crucial for designing systems that are modular, maintainable, and capable of evolving over time, whether it's choosing between serverless or microservices or deciding how to structure their deployment user using containers. Each decision plays a crucial role in long-term success of the application. As always, the key is to balance flexibility, scalability, and simplicity in the design process. Thank you for watching, and I hope this helps you in your software development journey.